Hello everyone, my name is Prasanna Kumar Reddy. I am presently pursuing my fourth semester in Teshwara College of Engineering, and the course name is Analysis and Design of Algorithms, and the course code is BCS 401. Now we are going to learn about the topic of Euclid's algorithm. As before going to the topic, we'll know the introduction, then we'll see the algorithm, then we'll go through an example and the advantages and disadvantages, and finally we'll come to the conclusion. Introduction. Euclid's algorithm, one of the oldest and most significant efficient methods, is to find the greatest common divisor of two integers, introduced by an ancient Greek mathematician Euclid around 300 BC and in his work Elements. This algorithm is based on the principle that GCD of two numbers also divides their difference by irrelatively replacing the larger number with the remainder of dividing the larger number by the smaller one. The algorithm efficiency reduces the problem size until the remainder is zero. The last non-zero remainder is the GCD, making Euclid's algorithm and fundamental tool in the number theory and computer science. Now we are going to see the algorithm. Euclid's algorithm step-by-step explanation. Start with two numbers. Let's call them A and B, where A is greater than B. And divide the first, divide and find the remainder. We need to divide A by B and the remainder let it become R. For example, that is R equals to A mod B. And replace A with B and B with R. Repeat. Repeat the process until B becomes 0. The GCD is the last non-zero remainder. Now we will see the example. Now before the example, we'll see the algorithm. That is, computes GCD m comma n by Euclid's algorithm. Input is two non-negative integers, both not both zero integers m and m. Output greatest common divisor. The input is we are going to give two integers, and output is we are going to get the GCD of the m and n of the two numbers. See, while n is not equal to 0, that is, if in the two integers, the n value, if it is not equal to 0, then we need to divide m by n, and the remainder is assigned as r, and we need to assign the n value as m and the r value, that is the remainder, to n, and we need to further keep on repeating the dividing process until the last digit that no more division can be performed. The last number which will be remained without division is called as the GCD of the two numbers. We'll see that one with an example. See, in this example, the m and n are 78 and 66. Now we are going to divide 66 and 78 and 66. The remainder is 12 when we divide it. See here, because 6 into 1 plus 12 equals to 78. So the remainder is 12. So now we are going to assign the n as m. That is, you can see in this. Wait, just a minute. This is m and this is n. So the remainder is 12. So now we are going to assign the n as m and the remainder as n. And again we are going to divide. Now we are going to get the remainder as 6. See, again on the further division, we will convert the n as m and the 6, the remainder as n, and the quotient is 2. So the remainder is 0. So we get the 2. No, we get the last remainder, that is this one, as the greatest common divisor. Like, if we keep on dividing till the remainder becomes 0, we'll take the previous number, which is we'll take the previous remainder, which is greatest, which is as the greatest common divisor. As you can see, once again we'll come through this example. Here the m and n, that is m is 78 and the n is 66, and the remainder we'll get is 12. And we'll convert the n into m, that again the m value will become 66 and the r will convert to n. So the n value will become 12, and we'll do the division part. So again, it 12 into 5 plus 6 equals to 66. So the 6 is the remainder. So again, the 12 we are going to convert it as m, and the remainder 6 we are going to convert it as n. So 6 2s are 12. So the remainder will be 0. So the previous one, the remainder is 6. So we'll take the 6 as the greatest common divisor. Now we'll see the advantages. Efficiency, simplicity, space efficiency, versatility, proven reliability. In efficiency, it computes the GCD quickly even for large integers due to its logarithm time complexity relative to the small of the two numbers. Simplicity. The algorithm is straightforward to understand and to implement, requiring basic arithmetic operations and a loop. Space efficiency. It operates with a constant amount of extra space, making it memory efficient. Versatility, Euclid's algorithm is not restricted by the size of the integers, making it applicable across a wide range of computational tasks. And proven reliability. It is being tested and utilized extensively in mathematics and computer science, ensuring reliability and accuracy in GCD calculations. Like the overall we can say is it is efficient, it is simple so that we can implement and we can use various arithmetic operations in the loop format, and it is space efficiency, and it is versatility, not because it is not restricted to the size of the integers, and proven reliability. It is being tested and utilized extensively in mathematics and computer science. It is used everywhere we can see now. And now we are going to see the disadvantages. Performance with larger numbers. For very large numbers, the number of iterations can be significant, making the algorithm slower and compared to other specialized methods of larger inputs. Handling large numbers. It may be impractical for extensively large numbers due to the limitations in memory or computational resources. Like we cannot use this algorithm to a large number. Like we can use, but it takes a large amount of time, making the algorithm slower. So it is very difficult to perform and handle with the large numbers, as you can see, because there are number of iterations. Like when we took the 78 and 66 example, it was like only three. But if you go to the three number or three-digit number iterations, it will be taking a more number of iterations. So it is very what we can say that algorithm makes like to perform the operation, it will be slower compared to the normal two-digit integers. And division operational cost. The algorithm heavily relies on the division operation, which can be relatively costly compared to the other arithmetic operations. Non-intuition for complex numbers. It is designed for integers, so adopting it for floating numbers or complex numbers requires additional considerations and modification. Like in this algorithm, we are given the input as integers, and if you give the floating numbers or complex numbers, it is difficult because we need to change the algorithm. That requires additional considerations and modifications in the algorithm. So this is a major disadvantage in the Euclid's algorithm, because we can give only integers. Instead of integers, we cannot give floating numbers, that is like decimals or complex numbers like the division parts, everything. We cannot give those numbers. We can give only the integers. And finally, we'll come to the conclusion. Euclid's algorithm efficiency computes the greatest common divisor of two integers, as I said, through interactive reduction based on their reminders. From reminder, we are going to convert it as the m and n, and we are going to perform the or further division operations, and the final remainder is considered as the GCD. It is straightforward and computationally efficient, operating in O log of m comma n time complexity. The algorithmic simplicity and effectiveness make it widely adopted in computer science and number theory. Its ability to reliably determine the GCD underscores its fundamental role in various mathematical computations and applications. Euclid's algorithm actually employs an elegant solution to the fundamental problem, demonstrating its enduring utility and foundational importance in computational mathematics and algorithmic design. Thank you.